Hi, everyone. Welcome to my talk on testing microservices. This is a bit of a case study that I had where I was working as head of engineering for a fintech company called Charrett Payments in Sydney, Australia, which is where I live. And we were, the fintech is basically a very small, it was about 250 people. It was created by three engineers, Cisco engineers, so there was a really heavy emphasis on development. In fact, I would say it was more tech than fin in that sense, and it was the engineers who really had the decision-making within the organization. There was about 250, half of these people were engineers. It was an XP house, so we did full hardcore test-driven development, pair programming, 9 to 5. We also we were iterating on a fortnightly basis, but we were wanting to move to continuous delivery, and our goal was to be able to deploy 3 times a day. But the whole context of where we were working on is we actually were a bank. And the bank that it was an SME bank, so the slogan that we had was to basically, for the SMEs to get their weekends back. And we wanted, being the Aussies, we kind of wanted to stick it up to the big guys, to the big banks, and we wanted to prove that, we could do these things, we could do things differently. So that was very much the kind of environment, a lot of experimentation, a lot of exploration in there, a lot of autonomy to try new things. And it was one of the things that really appealed to me when I went and started working there. To give you a bit of the technology, we had, it was RabbitMQ at the time, Java, pretty much, we had a bit of Docker, Jetty, Maven, that sort of environment. We used Jenkins for our CI. There was a couple of teams who were working on building a continuous delivery pipeline, but we hadn't actually got to that point yet. So what else can I say? We had a collective code ownership, so really there was just one trunk, and this really encouraged the teams to basically merge their code consistently, and that was one way of actually managing to find out whether there were problems really quickly and early on. From the testing perspective, as I said, I was head of engineering, but over the testing space. And one of the things that I was called in to do was, even though it was very much an XP house where we had the developers did a lot of the testing, they did all the automation, they still had, in the deep, dark corner in the background, they had this 5 testers sitting there desperately trying to manage some sort of testing 2 days before release. And they recognized, to be fair, they recognized that this wasn't necessarily very agile in their approach, and they wanted to improve that. So one of the things that I did when I first came there was to put these testers straight into the agile teams, so that they were working alongside the developers and learning about what was going to be deployed, what the features that were going to be created. We like to think we were disruptors too in testing. We didn't want to be seen as gatekeepers. We didn't want to be seen as necessarily automators. We felt that the developers were better at coding than we were, and it was their strengths, and they were responsible for doing all the test automation. So our goal was that we saw ourselves as risk investigators, and our responsibility was to identify potential threats that might create problems and to find those as early as possible. So constantly we were thinking about what might fail, what might go wrong. So in all of this environment, just to give you a little bit more context, so if you can sort of put it in, we had the programming side was test-driven development with, we had PACT, consumer-driven contract tests. We had something called cross-system tests, was a sort of an attempt to kind of do quasi end-to-end testing with the nearest neighbors of our microservices architecture. We did a little bit of unit performance testing. We hadn't quite matured in that space, but certainly that's where we were starting to head. And we had this issue with security where we had some decisions we needed to make about, well, what was going to be our strategy and approach to security testing. And we decided that actually we would have everyone responsible for security. So everyone went in on training for security testers and developers. And so it was really up to the teams to kind of manage that. So that has actually, in the end, that's proved not quite as sustainable as we hoped, so that they've now created a security team that manages that. As I said, the testing crowd, we identified risks. We did a lot of exploratory testing. And in fact, you know, exploratory testing lends itself really well to identifying risks, and so that was what we were focused on doing. We took up this concept of swarming. So if we saw a perceived threat or a risk that we weren't quite sure about, we would create a team to collect empirical data to try and identify and provide information to the rest of the organization about this perceived threat, allowing other engineers and allowing business people to make decisions about what they should do with that. We had a performance testing, small performance testing team. They were, but we didn't attempt to do end-to-end performance testing. Again, we focused on what were the core aspects of our system, and being in transactions, we focused all our performance testing around the switch. And so we spent a lot of money investing into an environment that replicated production right down, even down to the chip that was used in production in order to be able to really monitor the performance of that switch. We started looking at more deployment testing with microservices. That became a real issue for us. And as I said, we were doing security testing as well. Okay, just to kind of make sure we're all on the page, I'd just like to emphasize, I like this definition of microservices architecture. I like to think microservices as more of a concept than an architecture, but I like the idea that it's loosely coupled. We had REST APIs in between our microservices artifacts, but also this concept of a bounded context was hugely appealing to the developers and to the engineering department, because it meant that the agile teams could work in isolation to each other. And especially when we were moving to continuous delivery, we wanted to be able to deploy at least 3 times a day. And that meant we had to be able to deploy an artifact in isolation to other artifacts, and we couldn't worry too much about what was happening in the other teams. So it also meant from the developer's perspective is that they were able to choose their language, the code that they wanted to develop in. So if aspects of the system lent itself to a different type of programming language, they were free to explore into that. So when I first started, now this is a couple of years ago when we first started going into microservices architecture, and when we first started looking into it, I started investigating what were the kind of, well, how do we test microservices? What do we do? And there wasn't a lot out there when I first started testing microservices. Martin Fowler had this basically overview of how to look at automation for testing microservices. And that was really useful, and developers found out this was a very useful way to think about test automation. So we had our TDD, and the outcome of the TDD was our unit tests. We had integration tests, we had these cross-system tests, and we had PACT as well, and we were using PACT quite aggressively to try and be able to find those backward compatibility issues and help us in that space. But I had a problem with this because the article spent 1 sentence on exploratory testing, and I felt that to some degree we were missing out a little bit, because the automation is great for checking the known knowns, but it's not great for identifying is there a problem here, answering that question. And for us, we were focused on, well, where are the risks? Where can we find out where the problems might be? And so we had to look at alternative ways of trying to create a strategy. The other thing that was really quite interesting, and this is kind of more in retrospect, at the time we didn't really realize where we are, what sort of system state we were in, but we were developing in an MVP type environment. So we really didn't know the product, what the product was going to look like for our consumers. We did that on purpose. We wanted to experiment. We were disruptors. If we just went and imitated what someone else did, that wasn't necessarily disrupting the market. So we wanted to be innovative. And to do that, we needed very much a growth mindset and an open to learning and new ideas. It did mean an incredible amount of refactoring in our code and our ideas, but we felt that this was really important to maintain. The other thing that because of it was MVT, this made it, from a microservices perspective, quite hard to think about what is a microservice? What would the artifact look like? Because we didn't have a structure to compare against. So we might, create 3 or 4 microservices, and then, 3 months later discover that our abstraction was all wrong, and that we would have to restart again and thinking about, well, what is the correct bounded context for this? So there was a lot of refactoring of ideas and didn't necessarily lend itself to end-to-end test automation at all. So I like to think that we were very much in the complex place where it's hard to predict the outcome. Sometimes I think we were in the bottom left, right, but or even right in the middle. But it certainly made a very interesting way of trying to develop a strategy in that space. So one of the things that we sort of found that we started realizing when we were testing is that really the value that we add was not in the bounded context. It became immediately very apparent that as much as people developed within a bounded context, that the bugs didn't give a damn whether they were in bounded context or not. Bugs appeared wherever they wanted to. And, from that perspective, we had to start thinking outside of the bounded context. In fact, what we realized is that the real risk is actually between the bounded contexts. And that became apparent, if there was a lack of communication or collaboration between teams, it was then that the problems would start manifesting and the bugs would start appearing. So that was really useful for us to start identifying. Actually, in some ways, we had to have a slightly different approach and idea about what the risk in microservices might be. The other thing that we also realized is that from a tester's perspective, understanding the system is hugely important. Even from the technical perspective, we want to understand how it works, because the better we understand how it works, the more we can identify the potential threats. But also from the business perspective, we wanted to really understand what the business needed. And so for us, it was constantly trying to learn about what does the system do? What are people's expectations? And that really didn't have boundaries either. And looking at the system as a whole helped us really, we really made a point of trying to reach out and trying to understand beyond the teams. A couple of the things that we did, we created a Slack channel for all the testers within all the different teams so that we could share ideas about when we were going to deploy or when we're not going to deploy or things that we were struggling with. We also had regular stand-ups with all the teams, all the testers together so we could share information. And this proved really valuable. And also pairing with other teams, pairing with other testers cross teams, so learning about what the other teams were doing proved to be really useful too. We had a lot of challenges, and it was fun. I mean, they're not terrible challenges, but they were fun challenges to try and overcome. So for example, one example of bugs not really kind of staying and behaving themselves within their context was changes to database schemas. So one team might make a change to the database schema, and that change might not be communicated to someone else. And so that proved to be, problems would arise of that they were really down again to communication and not communication between teams. We discovered over time that as we were developed, we had 8 microservices at the start, and that was kind of okay. Our test environments could handle 8 microservices. That would be all fine, and we would sort of be able to manage that. But as the number of microservices grew, really pain started appearing. Couple that with the fact that we also had rapid growth, so our number of teams growing was significant as well. We would end up having queues for the test environment. We had one production-like test environment, and we would start having queues in that because teams would want to go in there and do some sort of end-to-end type test, and we found out that data was being compromised because teams were going on top of each other, and it became a real waterfall-esque type environment where actually this became a blocker for us to deploy rapidly. The config within the microservices was another thing. We noticed that, configuring 2 or 3 microservices in a test environment, yeah, that's all right, maybe 10, 15 minutes. But trying to do that for maybe 40, and suddenly you're finding that all your time is spent setting up test environments and trying to get security tokens for test environments and trying to change the config files to be able to, in all these different aspects. And it became really quite painful. The other thing was discovering performance bugs. Because we were constantly refactoring, we didn't see performance really as a risk initially for new products. And the reason for that was because we were experimenting with only a small number of consumers. So we thought, well, if we're going to have 5 consumers on an app, really, that's not going to be a huge issue. But once we started thinking about it in a bit more detail, we realized that potentially we were opening ourselves up to a real risk here, and that we needed to start at least thinking about performance and the trade-off between performance and security, and how we were going to manage that. So some of the things that we did, we started realizing that as much as microservices is about breaking things down small, really, and that we needed to test all those separate parts, that really the sum of the parts is greater, the whole is greater than the sum of the parts. And we started to take a step back from our focus on the actual artifacts themselves and start thinking about the system as a whole. We started thinking about business outcomes and really thinking of our testing in terms of business outcomes and trying to understand what value that the business gave. And we started developing strategies around that in order to be able to help really understand what the business needed rather than what microservices, the technical aspects of microservices. We created a diverse strategy. We looked at lots of different ways that we could, rather than trying to solve the problem, in one big solution, we broke down the problem into lots and lots of little ways that we could actually solve in small experiments. And then we would tackle those incrementally. One of the things that we did was diversify our test environments. Now, we already had test environments that were on the local machines, so that was really easy to get fast feedback for the developers, and that worked really, really well. But we had this one, as I said, this one test environment that really had a huge impact in our ability to deploy rapidly. And so one of the things that we did is we decided to purchase, I think it was about 6 boxes, literally, with about 300 gigabytes of memory in each. And we mimicked production. We set up a system that we could rapidly deploy production onto those test environments every 2 weeks. Now, the developers and the agile team still had to set up the microservices configurations themselves, but they had access to a production-like environment so that at any time they could actually do a microservices end-to-end or isolated test if that's what they wanted to do. The unintended effect of this was quite interesting because it really brought home to many of the developers the amount of pain it took to actually set up 40 separate artifacts in a microservices architecture. And for that reason alone, I call this experiment a huge success. We never really intended these boxes to remain there permanently because we knew we were going to have this continuous delivery pipeline which would enable us to be able to set up test environments really rapidly. So this was a sort of more of an interim experiment, an interim solution for us before we had our wonderful pipeline that was just around the corner. We set up other performance testing environments to encourage to perform these isolated experiments, to work on new features, and to try and do small bits of performance testing in isolation and collect data. We started looking at putting small parts of the system under stress and investigating what was the impact of those, what happens if we actually soaked the system, allowing the log files to basically fill up and see what the impact of extended log files were on our systems, looking at the memory and all these different aspects of the system under duress. Another thing that we looked at, we realized that one of the key risks in our strategy was that our data wasn't that great. So sure, we used production data that was scrubbed. We used a lot of that in our testing, but we didn't have a way to really diversify our data into something that was quite different. And so what we did is we worked with the developers to create some in-house tools where we worked with and they use the APIs to basically create tools that we could inject large amounts of different types of data into the systems to identify what would happen in the sort of edge case scenarios. We also started creating data sets of data so that we could rapidly put the systems into a different state, and then we would do exploratory testing in a state, instead of a zero state, we would be doing exploratory testing in a stress state or in a slightly different state from a clean zero. And that proved to be really useful as well. The other thing that we did was, and I mentioned it, was we recognized that we needed to diversify our skill sets. And one of the things that we did was we actually started looking at having test ops and having people who specialized in helping those test environments, helping that test data be ready for our testers whenever they needed it. So we could instantaneously, or even our developers, they could instantaneously pull down any data that they needed or wanted at any point in time. We also so those testers, we worked in that test ops. We also had very technical testers. As I said, they were embedded in the teams, working with the developers, doing a lot of pairing, helping maybe identify potential test cases for automation. We had a strategy meeting on how do we actually reduce our size of automation, because one of the things we realized is that we had an extensive amount of test automation, but it wasn't necessarily, we didn't really know whether it was valuable enough. So we experimented with deleting some of the tests and to seeing whether that really had an impact on our testing strategy, whether the amount of bugs increased rapidly and things like that. And that was really useful to do little experiments around that. We experimented with BDD, that was those sorts of things. And we didn't find those very useful for us because we were focused on the transaction space, but it was really useful for the team to just try those things out along with the tester working to help have a strategy within the team that worked through these sorts of ideas. And finally, what we did was we had a business type tester. We hired a business type tester who was excellent at building relationships with the business. So with sales, with marketing, and that tester actually went down and spent significant time just understanding how things worked and understanding the pain points that the business were facing. And we were discovering things that we had actually no idea, that often the time between you would have a consumer applying for applying for a terminal or wanting to become a customer, and the actual time that their terminal was sent out was something like 10 days. And just understanding that the other types of failure points within the business process really helped us understand our internal users better. And we also worked a lot with the UX people and the experimentation because they did a lot of going out to customers and trying to find out what customers really wanted. So we would spend time with them trying to understand our consumer better. The other thing that, from my perspective, was to give these people space to grow. And when we had this approach of hiring people who were really passionate, really curious, who were very passionate about their testing, and we wanted them to have the space in order to learn and grow. And we had this concept that every tester in the team acted like a test lead, that they had the responsibility and the autonomy to make decisions within their team about how they would drive their testing. And this was really important for us because all the teams were quite diverse anyway, and it seemed really stupid to have this one-size-fits-all approach to how testing should work, for the whole organization. And so it ended up very much the teams having very slightly different approaches to how they did their testing. Testability was something that we looked at too. Having in planning sessions, constantly asking how are we going to test this. Now I have to say that the developers in this space were absolutely amazing. I think TDD is incredible just for the concept of that you're constantly thinking, how am I going to test this? So this was a very natural progression for us to go into planning sessions and start talking about testability and talking about how we're going to test this system at a large scale. One of the things that happened while I was there was this, we had a change in the kernel in one of the terminals, this payment system. And we had to do some load testing in this space. Now, we didn't have a robotic arm or anything to tap the pay pass and see whether it's going to happen. And the tester came to the rest of the developers and the team said, look, this is really bad. I can't spend the next 3 days just kind of tapping this terminal. There's got to be a better way. And one of the developers in the team said, oh, actually, I've got an idea. And he was a train enthusiast. And he had this model train set at home. He said, well, how about we build this circle and we attach a credit card to the train, and it will just rotate round and round, and we'll just leave it there for 3 days, and we'll see what happens. And yeah, this is a bit of fun anyway. Hey, we can have a bit of fun doing this. And I think, it proved to be really successful. And people had a lot of fun thinking about it. It was for me, it was a great example of a testing, the testing team and the developers collaborating together to solve a testability problem. So to kind of summarize a little bit, one of the things that we really learned from this was when we're in a chaotic system or in a complex system, that we need to really be open up to experimentation and learning. We need to keep calm and learn our way through it. We didn't have one real clear strategy. We didn't have a one-size-fits-all strategy. We didn't have a deterministic outcome. We didn't try and predict what we were going to do. Instead, we sort of decided to perform these small experiments and learn as we went along. As I said, this was 2 years ago. And I think a lot has moved on since then. And I think some very exciting things are developing. For me, in particular, one of the things that I see is a change in focus from trying to do exploratory testing in production, prior to release, but looking at exploratory testing in production. And I think that's a really interesting area to continue exploring. We were looking at testing in production with our microservices, but we faced a huge problem being a bank, that we have compliance and regulatory demands, which meant that we couldn't necessarily do testing in production without going through a whole heap of rigor. But the way I approached, when I spoke to the regulators and I spoke to the internal auditors, the discussions where I was having was basically, it's actually more risky not to test in production than to try and do all your testing prior to production. And we really have to start moving into how can we mitigate the risk of failure. And through that sort of concept, we started introducing feature flags. We had sort of very small experiments where we were sort of testing out the regulators and testing out the risk profile of our internal auditors and seeing if they were willing to go with us on our journey. And I think that was one of the key things, is that they were willing to go with us on the journey. They recognized that their auditing, their concepts of auditing had to change as new technology approached and new ways of development were approaching, and they needed to become very much more open to a growth mindset of how things might work. So Elizabeth Henderson wrote this amazing article, blog post. She's from Pivotal, and she wrote this article about recovery over perfection. And it's something that I hold dear to my heart, because I think it's really how we need to start thinking about the future. That rather than trying to get our software to work absolutely perfectly before release, that we need to be looking at how we can recover quickly. From a testing perspective, this absolutely fascinates me, because I think, well, okay, if that's the case, what are we doing about testing for recoverability? What are we doing about actually seeing whether, and measuring the amount of time it takes to recover for these microservices? And looking at really trying to replicate some of the risks that might come. I think these are the sorts of questions that would be fascinating to try and look at and explore and challenge. And also looking at really trying to understand what quality is. What is quality from our business perspective? What do they really care about? All my life in testing, I've been told that quality and speed are antithesis to each other. You can't have quality along with speed. And I find this really frustrating as a tester, because every time I go into a business environment, every time I go and work in a development environment, it's always about going faster. And I'm like, man, how are we going to have quality if everyone's so fixated on going really, really quickly? And it suddenly occurred to me, it's like, well, actually, maybe speed is an attribute of quality. For our businesses, actually being able to be flexible and react to change out in the market is really important to them. And maybe as a tester, I need to start appreciating that and respecting that. And as a tester, maybe I need to start thinking about how can I actually help that speed to delivery, rather than saying that it's actually impacting quality. So what the things I've started to look at is, how can I reduce waste in the system so that will enable us to deploy more rapidly? What waste exists in testing? And I think when I look at exploratory testing and where it came from in the past, it was looking at removing a lot of the waste. All those really heavy test cases, manual test cases that people were writing, now you could actually go in and start testing straight away. So taking that concept of removing waste, looking into the automation builds and trying to identify potential waste in test automation. Why am I, just because my test is flaky, I'm running that 3 times, right? So if everybody's running their test 3 times because it's flaky, that's really going to build up the amount of potential waste in building in your build. And so trying to think about ways, and I can facilitate that. How can I help that? How can I identify these types of risks? I think risk in infrastructure as well. And the more and more I see it is that actually the real value that we in testers can give in microservices is to be looking at these infrastructure things, to be looking at observability. Work that Charity Majors is doing, I think, is absolutely fascinating. And I see this, there's a real synchronicity of ideas between some of the quality work that's out there and some of the SRE work that's out there. And I think that's something that we as testers and in the quality community can start getting more engaged with. All right, there's a bit of reading there that you're welcome to take and follow up. I think in particular, the one that I find quite fascinating is, I haven't got it down there. Oh, testing microservices the same way by copy construct. She's really excellent article about how to do thinking about exploratory testing in production rather than trying to do that before. I think one of the things that I've really realized is that having testers doing exploratory testing in stories is really a waste of time. I don't see a lot of value in doing that anymore, so I really identified with what she said. To summarize, we need exploration and we need automation. Both are vital. Having risk to help us decide where to test. Think about risk as what might fail, what might go wrong, not in just technical terms, but also in business outcomes. And I think swarming is a great way to be able to target risk really rapidly. So I would encourage anyone in that sort of profession to actually create small teams that will be able to identify and tackle risk and provide empirical data to be able to then tackle that problem systematically. Personally, I'm not a fan of end-to-end automation, especially GUI end-to-end automation. In all my history of testing, I've yet to be proven that it adds a huge amount of value. I have a heuristic where I say no more than 10, which is really, let's try and limit the amount of end-to-end tests. I still don't think we have solved that problem, even with AI, just yet. And mimic production where useful. We don't necessarily need test environments that are exactly like production. They can be useful, but I think actually thinking about testing in production is really where we need to start focusing our efforts. And that's it. Thank you very much for your time and your ears.
Well, thank you so much. We are even a little bit ahead of schedule,
okay.
So let's have some questions probably. Do we have questions? Yes, we do.
Would you like me to read them?
Yeah, you read them.
Okay, we'll start with the first one, which is, what is the first thing from your lessons learned that you would bring to the next new/engineering-focused microservice architecture company? That was poorly worded by me, sorry.
That's okay. Oh, wow, that's a great question. I think really is to adopt a learning mindset. One of the things that we said when we were working there is actually don't expect to be adding value in the first 3 months. There is so much to understand and learn about your domain, about the technology, and really, if you really want to understand risk, you need to understand your models, you need to understand how people are working, you need to understand your culture. So bringing all that into your testing strategy is really useful if you're allowed the time. So that's what I'd be trying to do, is encourage time and space for learning.
All right. What's the right approach in order to test event-driven asynchronous services, where things happen only after some event or a chain of them have been triggered?
I don't know. Pass.
Perfect. Perfect. Did you do integration testing?
You know, that was really interesting. So a lot of the developers read about J.B. Rainsberger's integration tests are a scam, and they did a lot of they identified a lot with that. So what they tried to do was abstract out their unit tests to a higher abstraction in order to be able to deal with some of the issues. But we tried as much as we can. We did some cross-system tests, which I guess is a form of integration testing. We had PACT, which was consumer-driven contract testing, which is a form of integration testing, I guess, you know. So we did have forms of integration testing, but we had very little end-to-end testing. And if we did do the cross-systems tests, they were with our nearest neighbors. It was an attempt to do the whole user journey.
Okay. And how about if it is natural human error, how can one test that communication solves problems? For example, schema changes.
Well, how can we actually trust that any problems get solved? I mean, I think, you know, the nature that we're working as humans and that there is error is going to mean that, yes, we're going to make mistakes. The key is that we have a culture that we're open to those mistakes are going to happen. Testing is not going to find every single bug in your system, whether you like it or not. I don't believe there's such a thing as exhaustive testing anyway. So the focus is how can we find bugs that matter? How can we find things that we can actually do something about and mitigate to our best ability?
Basically take a leap of faith, right?
Sorry?
Basically take a leap of faith and trust everything will work out.
I like to think about informed decisions rather than a leap of faith, but if we can
Informed
make as many
leap of faith.
informed leap of faith,
Okay.
absolutely.
Thank you so much. I think we should be proceeding with the lunch break, which will be until 13:30. So set your alarm clock for 1:30 and be back here. Thank you so much. Enjoy your lunch break, guys. See you later.